Welcome to The Explainer. Today, we're diving into LangExtract, a really powerful new open source tool from Google. It's designed to solve a problem that, let's be honest, almost every developer has faced: how to turn messy, unstructured text into clean, genuinely useful insights. You know, the Google developers blog puts it perfectly. So much of the world's most valuable information is just locked away. Think about it. We're talking about critical data in medical reports, legal contracts, financial documents. It's all just sitting there in paragraphs of plain text, which makes it almost impossible to analyze in any meaningful way. And this has always been the fundamental challenge, right? Getting from the absolute chaos you see on the left to the beautiful, clean, structured data on the right. Doing that reliably and accurately, especially at scale, has been a huge headache for years. Okay, so let's really get into this problem. I mean, with all the incredible power of modern AI, why is this still so difficult? Why is it so hard to get this right when you're building a real product? Well, if you've ever tried it, you know that just throwing a large language model at a document and saying, hey, extract the data, can be a total minefield. The model might just make stuff up. That's hallucination. Or it might paraphrase something important instead of pulling out the exact words. You might get a different output format every single time you run it. And maybe the worst part? There's often no traceability. You have no idea where the information actually came from in the original text. And this is exactly the problem that Google's new open-source Python library, LangExtract, was built to solve. It's not just another wrapper around an API. It's a real precision tool specifically designed to fix those core failures of just winging it with an LLM. Think of LangExtract as a smart control layer for the LLM. It's all about bringing reliability and trust back into the process. It basically takes this incredibly powerful but sometimes unpredictable tool, the LLM, and makes it behave in a predictable way. So instead of getting a slightly different answer every time, you get clean, structured data you can actually count on. So how does it pull this off? How does it build this foundation of trust? What's the secret sauce that makes LangExtract so effective? It all boils down to this brilliantly simple three-step workflow. First, you just define what you want with a clear prompt and a really good example. Second, you run the extraction. And third, and this is so cool, you can instantly visualize the results in an interactive report to check exactly what the model did. This brings us to what I think is LangExtract's killer feature: source grounding. Every single piece of data it pulls out is mapped back to its exact character location in the original document. This gives you complete traceability. It just eliminates all the guesswork and lets you verify every single output. And the second huge feature is reliability. By learning from those examples you give it, LangExtract enforces a totally consistent output structure. For models like Gemini, it uses controlled generation to guarantee the output is always perfect, structured, and ready to be dropped right into a database. So, no more parsing messy, inconsistent JSON. It's also incredibly flexible. It works right out of the box with the big cloud APIs like the Google Gemini family and OpenAI's models. But, and this is really important, if you're worried about privacy or cost or you need to work offline, it also supports local models through Llama. You get to pick the right tool for your specific job. All right, so we've seen the how, but let's talk about the what. Where is a tool like this actually being used to create some real value? The short answer is absolutely anywhere there's text with valuable information inside. Because you define the task with your own prompts and examples, it's adaptable to any field you can think of, without the massive cost and time of fine-tuning a whole new model. We're talking healthcare, finance, law, and even things like literary analysis. A fantastic real-world example of this is RAD-Extract. It's a live demo Google put out that uses LangExtract to take these super dense, complicated radiology reports and automatically convert them into a structured format, highlighting the key findings. This makes things so much clearer, and it changes how that data can be used for research and patient care. But this goes way beyond just pulling out facts. By identifying not just things, but the relationships between those things, LangExtract's output can be used to build powerful knowledge graphs. And these graphs are the perfect fuel for advanced AI systems like retrieval augmented generation, or RAG. So instead of just searching through raw text, a RAG system can now query this structured knowledge, which leads to way more accurate and context-aware answers. So this brings us to the big picture. Why is a tool like this so important right at this very moment in AI's evolution? We are right in the middle of a massive shift in the industry. For years, the old way was to take a model like BERT and painstakingly fine-tune it for every single specific task. It was rigid, it was slow, it was a ton of work. The new reality is using these massive general-purpose LLMs as a flexible service. And LangExtract is built from the ground up for this new world, giving you way more flexibility and traceability with just a fraction of the setup time. So let's recap the main takeaways here. LangExtract lets you turn that messy text into clean, reliable data. You can actually trust the results because of source grounding. The whole workflow is so much simpler. You're using prompts, not fine-tuning. And it can scale from a single sentence to a whole book, creating structured data that can power the next wave of AI systems. Now that tools like LangExtract are finally solving the headaches and unreliability of data extraction, the question is changing. It's no longer, can we get the data? It's, what will we do with it? So I'll leave you with this thought. If you could reliably structure any text you wanted, what new insights would you unlock?